Assalamualaikum warahmatullahi wabarakatuh, and hi again. In this video, I will continue with a number of examples on testing a single population mean mu, which is the first parameter covered in chapter 4 on test of hypothesis. Let's look at the first example in the next slide. Please refer to exercise 4, question 1 in page 107 from Statistics for Engineers textbook. Here the question is, test the hypothesis that the random sample given by the sample data came from a normal population with mean 30.5. The standard deviation is known to be 0.1. Use alpha equal to 0.05. Based on this question, it is obvious that you ought to run a hypothesis test to solve this question, which is covered in chapter 4. We are not talking about estimating an unknown parameter. Neither should we construct a confidence interval for a particular parameter. Right? So this is not about chapter 3, but chapter 4. Therefore, to run a hypothesis test, remember the 6-step conventional procedure? However, before going into the procedure, let's first recognize the information given in the question. What do we know from the question? Yes, we have the sample data. So write down the information using correct notations. For example, we know that the sample size n is 8. The sample mean x bar can be obtained from calculator directly, which is 30.425. If we want to state the sample standard deviation as, then proceed writing it down. The question is, are we going to use S in this particular question? Let's identify what else do we know from the question. Yes, we need to identify what parameter we want to test. This is the first step of testing procedure. If we look at the question again, we want to test the population mean mu. So this is our parameter of interest. When we know we have to test mu, then remember we have 3 cases. Identify which of the 3 cases should we use. Since sigma is known to be 0.1, we have case 1, that is to use a z-test. Therefore, we can proceed with the test at alpha level of significance, which is 0.05. But how to formulate H0 and H1? Look at the question again. Test if the data came from a normal population with mean equal to 30.5. This is the hypothetical value of mu under H0, where under H0 we have mu equal to 30.5. What about H1? Obviously, under H1, mu should be not equal to 30.5. Do you agree? The question clearly asks to test if the sample data came from a normal population with mean mu equal to 30.5. Or alternatively, you can ask whether the sample data came from a normal population with mean not equal to 30.5. So we have a two-sided test in this question. The decision rule is then reject H0 if modulus of z-test is greater than a critical value z alpha over 2, which is z 0.025, which is 1.96 from table 4 in the stats table booklet, page 34. If you expand the modulus, the decision rule can also be written as reject H0 if z-test is smaller than negative z 0.025, which is negative 1.96, or if z-test is greater than z 0.025, which is 1.96. Let's look at the complete solution in the next slide. Let us proceed with solving the question we discussed in the previous slide. We already knew the null hypothesis H0 and the alternative hypothesis H1, as well as the decision rule or the test criterion for this question. Now we need to calculate the test statistic, which is z-test, defined by the sample mean x bar minus the value of mu under H0, that is 30.5, divided by the known sigma 0.1 over the square root of the sample size 8. Here we do not use the sample standard deviation S in the formula, although we can get its value from the calculator. Since we know the value of population standard deviation sigma, then sigma is the priority to be used in the formula for z-test, not the sample standard deviation S. After substituting all notations with their corresponding values, z-test is equal to negative 2.1213. You may want to correct the answer given in the textbook on page 182, which is a typo error. Apology for this typo error. Now we can proceed with the last step of hypothesis testing, which is making decision and conclusion. What we need to do first is to compare the z-test value with the critical value 1.96. Since z-test is negative 2.1213, its modulus is 2.1213, which is clearly larger than 1.96. Therefore, we can decide to reject the null hypothesis H0. However, we cannot simply stop here, since we haven't really answered the question, which is testing whether the data came from a normal population with mean equal to 30.5 or not. Now, since we reject H0, what does it mean? We can conclude that the sample data provide a strong or sufficient evidence at the level of significance alpha equal to 0.05 to reject the hypothesis that the sample data came from a normal population with mean mu equal to 30.5. That is, we have evidence to reject that mu equal to 30.5 in favor of H1, which says mu not equal to 30.5. Alternatively, we can also simply conclude that we have evidence from the sample data that this data actually came from a normal population with mean mu not equal to 30.5. Now look at another example based on task 4.2 in page 90. Suppose you are a buyer of large supplies of mobile phone batteries. You want to test the manufacturer's claim that his mobile phone batteries can last, on average, more than 900 hours. You tested 40 batteries and found that the sample mean lifetime of the batteries is 922 hours with the sample standard deviation 68 hours. Should you accept the manufacturer's claim, use alpha equal to 0.05. Here again we have a test of hypothesis. This time we want to test on manufacturer's claim about his battery's lifetime. As before, we need to first recognize the information provided in the question. As we can see, we have a value of sample size n equal to 40. The sample mean x bar equal to 922 hours, and the sample standard deviation s equal to 68 hours. So please write down all this information using correct notations like this: n equal to 40, x bar equal to 922, and s equal to 68. Next, what is the parameter of interest? Since we want to test the manufacturer's claim about his battery's lifetime, that he claimed can last on average more than 900 hours, then the parameter of interest here is the mean lifetime, which is mu. Since it is mu, then again we need to identify which of the three cases to be used here. It's all first depend on whether the population variance sigma squared or standard deviation sigma is known or not. From the question, we do not have any information on sigma or sigma squared value. Therefore, sigma or sigma squared is unknown. Next, look at the sample size. As we noted earlier, n is 40, which is considered large. Therefore, we have case 2, that is to use a z-test in this task question. Now we can run a test at alpha equal to 0.05. What are the null and alternative hypotheses H0 and H1 for this question? Since we know under H0 we should always have an equality sign, then we can write H0 mu is equal to 900. What about H1? Let's look at the question again. We are to test the manufacturer's claim that his batteries will last an average more than 900 hours. The word more is a very strong keyword that helps us to write H1. This statement, that is the manufacturer's claim, should be under H1, that is mu is more than 900. Remember the rule, we do not have equality sign under H1. It should be either unequal, less than, or greater than. So for this question, we have a greater than sign under H1, which indicates a right-sided alternative test of hypothesis. The decision rule or rejection rule will follow what we state under H1, which will be further described in the next slide. Proceed with the solution to task 4.2. We already decided on the null and alternative hypothesis, and we also knew that we have case 2 for this task question, that is to use a z-test as the chosen test statistic. Since we have a right-sided H1, then the decision rule is reject H0 if z-test is greater than z-alpha, which is z0.05, given by 1.6449 from the statistical table. Remember, we must use the whole alpha for the critical value, as we have a one-sided test, which in this case is a right-sided test. Notice also when I said the decision rule follows what we state under H1, since we have a right-sided H1 denoted by a greater than sign under H1, then in the decision rule, the critical region will be on the right of z-test denoted by a set of z values which are more than the critical value 1.6449. So the notations greater than sign has to be consistent. After stating the decision rule, next is to calculate the test statistic, which is the z-test. This time the z-test is defined as the sample mean x bar, which is 922, minus the mu value on H0, which is 900, divided by the sample standard deviation S, which is 68, over the square root of the sample size, 40. We do not use sigma in the denominator this time because sigma is unknown. Instead, we estimate or substitute sigma with the sample standard deviation S. The value of z-test is then 2.0462. Based on this value, we can now make a comparison between the z-test and the critical value before making a decision. Since z-test is obviously greater than 1.6449, which indicates that it falls in the critical region on the right, therefore, our decision is to reject the null hypothesis H0. Again, we cannot just stop here. What about the conclusion? Should we accept the manufacturer's claim? This is exactly the question that we have to answer. One possible conclusion is that we can say that we have a strong or sufficient evidence at the level of significance alpha equal to 0.05 from the sample data to reject H0 and support or accept the manufacturer's claim that his mobile phone batteries can last on average more than 900 hours. Look at another example. A packing plant is considering to buy a new machine for packing cartons with glasses. Before deciding to buy, the plant observes the capability of a new machine through the machine's packing time per carton in seconds. The plant will decide not to buy the new machine if the packing time per carton is, on average, at least 45 seconds. The plant took a sample of 10 cartons packed by the new machine and found the total packing times is 437 seconds and the standard deviation is 1.5 seconds. Run a statistical test to decide if the packing plant will buy the new machine when the probability of type 1 error is 0.025. Once we glance through the question, again identify or recognize the information provided in the question. Here we have the sample size is 10, that is n equal to 10. Next, do we have the sample mean? It's not given directly in the question, right? What we know from the question is the total packing time is 437 seconds. In notation, we can write the sum of x is 437. Therefore, the sample mean is the total 437 divided by the sample size 10, which gives us 43.7 seconds. Next, we know the sample standard deviation is 1.5 second, so we can write S equal to 1.5. What else can we write down? What about the parameter that we want to test? The parameter relates to the plant's decision whether to buy or not to buy the new machine, and this has to do with the average packing time per carton, right? So the parameter of interest in this example is clearly the population mean mu. Since it is mu, then again we need to identify which of the three cases we should use here. First, look at whether the population variance sigma squared or standard deviation sigma is known or not. From the question, we do not have any information on sigma squared or sigma. Therefore, sigma or sigma squared is unknown. Next, look at the sample size. As we noted earlier, n, the sample size, is 10, which is considered small. Therefore, we have case 3, that is, to use a t-test, not a z-test in this example question. Now we can run a test at alpha equal to 0.025. How do we know alpha is 0.025? It's not given directly in the question, right? But we know the probability of making type 1 error is 0.025, which is exactly the level of significance that we can use to run the statistical testing. Now, what are the null and alternative hypotheses H0 and H1 for this question? Since we know under H0 we must always have an equality sign, then we can write H0 mu is equal to 45. But what about this plant statement? The plant says it will not buy the new machine if the machine's packing time is on average at least 45 seconds. The word at least means 45 and above, right? This should be a statement under H0, since the statement contains the equality sign as well. Therefore, to be precise, under H0, mu is at least 45, where the plant will not buy the new machine. What about H1? Statement under H1 has to be totally contradicting with the statement under H0. In this case then, it should be apparent that under H1, mu should be less than 45 seconds, where the plant will decide to buy the new machine. The decision rule will next follow what we write under H1 as illustrated further in the next slide. Now we look at the complete solution to the example question in the previous slide. We already decided on the null and alternative hypothesis H0 and H1, and we also knew that we have case 3 for this question, that is, to use a t-test as the chosen test statistic. Since we have a left-sided alternative hypothesis H1, then the decision rule is reject H0 if t-test is less than the left-sided critical value, which is negative T alpha nu, where T alpha nu is negative T 0.0259 given by negative 2.262. The T value can be obtained from the statistical table booklet page 35. Remember, we must use the whole alpha on the left for the critical value, as we have a left-sided test in this example. Notice also when I said the decision rule follows what we state under H1, since we have a left-sided H1 denoted by a less than sign under H1, then in the decision rule, the critical region will be on the left of the left-sided critical value, that is, the set of t values being less than negative 2.262. After stating the decision rule, next is to calculate the test statistic, which is the t-test, defined as the sample mean x bar, which is 43.7, minus the mu value under H0, which is 45, divided by the sample standard deviation S, which is 1.5, over the square root of the sample size 10. We do not use sigma in the denominator because sigma again is unknown. Instead, we estimate or substitute sigma with the sample standard deviation S. The value of the test is then negative 2.7406. Based on this value, we can now make a comparison between the t-test and the critical value before making a decision. Since t-test value is clearly smaller than negative 2.262, which indicates that it falls in the critical region on the left, the decision is then reject the null hypothesis H0. Again, we need to answer the question, will the packing plant buy the new machine? When we reject H0, we can conclude that the sample data provides a sufficient or strong evidence at the level of significance alpha equal to 0.025 that the average packing time is evidently less than 45 seconds per carton. Therefore, the packing plant can be advised to buy the new machine. Based on the question from the recent example, assuming other things remain unchanged, such as the sample size, the sample mean, the sample standard deviation, and also the packing plant's condition to buy the new machine, will you change your decision and conclusion if the level of significance alpha at which you run the statistical test has now reduced or decreased to 0.01 or 1%. Justify your answer. Since other things remain unchanged, it means we still have the same null hypothesis H0 and the same alternative hypothesis H1, which is a left-sided alternative hypothesis. And we also have the same test statistic value, that is the t-test given by negative 2.7406. However, the critical value in the decision rule or rejection criterion will change because now the alpha value has decreased to 0.01. Therefore, the new decision rule will be reject H0 if t-test is less than negative t0.019, which is negative 2.821. By comparing the t-test and the new critical value, we can see clearly that t-test is larger than the critical value. Therefore, we fail to reject H0, which suggests that the mean packing time could be at least 45 seconds per carton. The conclusion is then, the sample data do not provide a sufficient evidence at alpha equal to 0.01 that the new machine's average packing time is less than 45 seconds per carton. Hence, the packing plant will not buy the new machine. So to answer the question whether you will change the decision and conclusion if alpha is reduced to 0.01, the answer is yes, you will change the decision and conclusion when alpha decreases to 0.01. How to justify this answer? Well, because the test statistic t-test is now outside the critical region. Let's look at a general rule for a statistical test. By and large, if you reject H0 at a particular level of significance alpha, you will certainly or definitely reject H0 if alpha increases, because the test statistic will still remain in the new expanded critical region. However, you may or may not reject H0 if alpha decreases, because the test statistic could either be still inside or already outside the new reduced critical region. You can check this general rule by comparing the test statistic with the corresponding critical value at the specified level of significance alpha and observe if the test statistic will fall in the critical region or acceptance region when you change the level of significance. Having done a number of examples on testing a single population mean mu, let us do a checklist on this topic. At the end of listening to this video, that is, learning this topic, are you now able to first identify the 3 different cases in testing a single population mean mu? Remember, the 3 cases have to start with whether you know the population variance sigma squared or population standard deviation sigma or not. If you know, then instantly it is case 1, else look at the sample size. If the sample size n is large, you have case 2. If not, you have case 3. What about the second learning objective? Are you now able to choose and calculate the chosen test statistic for each case correctly? Remember, cases 1 and 2 make use of z-test, whereas case 3 makes use of a t-test. What about the third learning objective? Are you now able to perform a hypothesis test on the single population mean mu? Remember the testing procedure and the types of tests, the two-sided, the left and the right-sided test? These are important when you are to carry out any statistical testing. Lastly, are you now able to achieve the fourth and the last learning objectives of this topic? Make sure at the end you know how to make a correct decision and hence write a sound and practical conclusion about the population mean mu. That's it for testing the single population mean mu, guys. We'll see again in the next video on testing different population parameter. Until then, thank you very much for watching and Assalamualaikum warahmatullahi wabarakatuh.